Good day, everyone. So this morning we are going to be looking at conic section. Just a moment. So we are going to be looking at conic engineering graphics modeling. We are going to be looking at conic section, and there are various methods of construction. So basically, what are conic sections? They are sections of a right circular cone obtained by cutting the cone in various positions relative to its axis. Three sections of the cone that can be obtained are ellipse, parabola, and hyperbola. So you can see how an ellipse is formed if you cut the cone along the plane BB. You are going to form an ellipse. But if you cut it more like almost horizontally along CC, you will form a parabola. Then if you cut it such a way that you are cutting it up to the base, middle of the base circle, you are going to form an hyperbola. So basically, conic is defined as locus of point moving in a plane such that the ratio of its distance from a fixed point F to the fixed straight line is always a constant. That ratio is called eccentricity. So what we're trying to say is that there is a fixed point F and there is a straight line DD. So the ratio of points from this fixed line, let's look at point P, P from F to P from E, which is along DD, is called the eccentricity. Now, if the eccentricity is less than 1, you have an ellipse. If it's equal to 1, you have a parabola. And if it is greater than 1, you have hyperbola. And that fixed point F is called the focus. It's called the focus. That fixed point F is called the focus. So the fixed line DD is called the directrix, while the axis, which is CA now, is called the axis. Then the point at which the conic cuts its axis is called the vertex. Okay, so knowing those basic information, so CA is the axis, V, where the conic section cuts the axis, is the vertex, F is the focus, DD is the directrix, and PF over PE is the eccentricity. So now in this class, we look at how we can construct an ellipse, and there are 4 different methods to constructing an ellipse. And the first one is auxiliary or concentric circle method. The second is approximate method, focal point method, and eccentricity method. So looking at the concentric or auxiliary circle method, let's assume we are going to have this example now. The major and minor axes of an ellipse are 120 mm and 84 mm long, respectively. Draw the ellipse using auxiliary or concentric circle method. So the first thing we'll do is to draw the major axis. The major axis is the longer line, while the minor axis is the shorter line. So from this question, the major axis is the 120 mm line, and the shorter axis is the 84 mm line. So we draw those 2 axes. As we can see, PQ is 120 mm, and RS is 84 mm. So first you draw PQ, then bisect PQ to get the center. After you do that, you then measure RO. So if this is 84, RO will be 42. So you measure RO, you cut up and you cut down with your compass. So that would be RS. So after that, you have to draw, using point O as center, draw circles of radius PO and radius RO. So this is point O as center. Open your compass to P as your radius, then with the center at O, draw that bigger circle. Then to draw the smaller circle inside, put your compass at point O and open it to R, and with that radius, draw the smaller circle. So that is the next step. So after that, you divide the circle into 12 equal parts. Divide the circle into 12 equal parts by radial lines through point O. So these 12 equal parts will be what? 30 degrees each. If you divide 360 by 12, you have 30. So how do you divide the circle into 12 equal parts? Let me assume that I have, let me pick a pencil too now. So let's say this is my, don't mind me, this is my circle. I have this line drawn already. And I also have my minor angles drawn. So I want to share this into 12 equal parts. What I will do is that I will pick the radius. This is point O. All right. I will measure P, and this is point Q, right? So I'll measure OQ as my radius. And then I will come here, come to Q, cut up, cut down, come to this point also, cut here, come to this point, cut here, come to this point, cut here, and cut here. So join these two lines through the center, join them together, join these two also through the center, together, join this one through the center, and then join this through the center. So we have our division. That's how to divide a circle into 12 equal parts. Okay, so after dividing the circle into 12 equal parts, what we now do next is to, at the point where the radial lines meet the major auxiliary circle, project vertical lines. So at this point, where the major line meets there, okay, project down a vertical line. Of course, you need to use your set square to make sure that line is parallel to the RS line. And then at the point where they meet the minor axis circle, project an horizontal line parallel to the PQ line. Okay, so you do the same at every point here. Like that. So So with that, we have something like this. We have something like this. So after that, you begin to join this point with your French curve. Join all these points together smoothly with your French curve. So how do you join? You first of all make sure that you find a curve such that 3 points are touching you find a point in your French curve such that it touches 3 points at a time. So, and like that, you join all through, and then you form this smooth ellipse. Okay, so that is the concentric circle method, auxiliary circle method. The next one we're going to look at is the approximate method. So the same question, we want to draw with approximate method. So in this method, you draw the axis, the major axis and the minor axis. And after that, you join PR with a straight line. Join PR with a straight line. Join PR with a straight line. After you join PR with a straight line, the next thing is to using arrow and radius PO. Using PR, join P to R with a straight line. With center O and radius PO, draw an arc to intersect RS at T. So this is RS. So with center O and radius PO, draw an arc to meet RS with center O and radius PO. So from here, with this radius, draw an arc to meet RS somewhere here at T. So after that, using R as center and radius RT, draw an arc to intersect PR at U. So this is PR at U. So now you open your compass to radius RT with R at center, draw an arc to intersect PR at U. So this is U. So what we are saying is this. So now after we have gotten our U, using our and bisect PU. So the distance between P and U now, you bisect it. You draw it down to intersect PQ at A and TS at B. So you bisect PU, join the lines to intersect PQ at A and then TS at B. So that is the next step. So mark point A and B. So the mirror of it will be that A this other side. So what do? You put your divider or your compass. Open your compass from O to A, take the measurement, and come here, then you cut. Open your compass from O to A, take the measurement, come here, and you cut the same thing. So that is, this will now be A prime. And then similarly, open your compass also to B and S. B and S, no, this is RS, so B and S, and then you cut. Know the distance also. Open your compass to BS, and from R, you cut. So this becomes B prime. That's exactly what you have here. That's exactly what you have here. So I haven't done this. Draw a circle with radius A prime Q with centers A and A prime. Draw a circle with radius A prime Q and AP. So what we're saying is that after you have gotten this, with center at A, open your compass to AP, draw a circle. Come also to A prime Q, open your compass to AQ, draw a circle. Okay? So after you have drawn that circle, similarly, with centers B and B prime, draw arcs with radii BR and B prime S. So what we're saying is that from B prime now, from B prime as your center, open your compass to S, then draw a semicircle, draw an arc to touch the two circles. The same thing from B, open your compass to R, and then with B as center, draw another arc to touch the two circles at the top. So taking the outline and you have your ellipse. So that is the second method. The third method is the focal point method. So using the same example, you are drawing to draw the major axis PQ and the minor axis. So the first thing is to locate the focal point using center R. Okay, draw an arc with radius PO. Using center R now, draw an arc. So first of all, you get PO as your radius. So using center R and with radius PO, draw an arc. So that arc will become the focal point. So with radius PO and center R, draw an arc. So that arc comes like this. So this is your F. And let's call this one F prime. Okay, so that is your focus. F1 and F2, any way you want to call it. So we have been able to locate our focus. And then after that, the next step is to divide PQ into 12 points. To divide PQ into 12 points. So at this stage, I will show us how to divide a line. Assuming I have this straight line. Sorry. And I want to divide it. So the first thing is I will draw another line at any angle to that line, but it should join the beginning of that line. So I draw another line. So I open my compass to any radius of my choice. And from here, I cut this point 1. Using it as the net center with the same radius, I cut again. I cut again. I cut again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So what I will do is that I will join this 12th one to the end of the line with a straight line. I will join the 12th one to the end of the line with a straight line. So then I will draw parallels to this line using the next points, the remaining points. So using my set square, 45 and 60 degree set square, position in such a way that it will lap on this line, and then you just slide, draw the next point, draw the next point, draw the next point, like that, like that. So you can number 1, 2, 3, like that. You can number the lines like that till you have 12. So that is that. Now, after doing, and that's how this line was divided into 12 parts. So after dividing the line into 12 parts, using F1 and F2 as center, draw arcs with radii P1. What are we saying? We're saying that with F1 at center and radius P1, in other words, open your compass from P to 1. Put it on F. Draw an arc down, draw an arc up. But if you look at it, you put it, it will be on P. And then come to Q. Open your compass from Q to 1. Put it on F2. Cut the previous arc. So let's look at 4.2 now. Put your compass on P to 2. Then with F1 at your center, cut up, cut down. Now open your compass from Q to 2. That's Q2. Now with F2 at center, cut the previous arc and cut it. Same thing with P3. Open your compass from P to 3 with F at center, cut up, cut down. Now from Q to 3 as your radius with F2 at center, cut the previous arc you have done. So you do that up until you get to 12. So that is how you create all these points. Now that you have created the points, easy to join with your French curve. You join them smoothly with your French curve. And one simple way to ensure that it is smooth, make sure at least 3 points falls on the curve before you join. Then we'll come to the last method, which is the eccentricity method. So here an ellipse is locus of a point which moves so that ratio of its distance from a nearer fixed point to a fixed straight line is a constant and is less than the ratio is less than 1. So the ratio is called eccentricity. For ellipse, eccentricity is less than 1. What are we saying? Eccentricity is what distance of the point from the focal point over distance of the point from the directrix. So in figure C4.1, you can see that TF, this is the focus, and then TF, this is the point along the ellipse, moving along the ellipse. So TF is what? The distance of the point from the focus, while TE is the distance of the point from a directrix DD. Okay, so that is basically, so P and Q are what? Vertices. Remember we said the vertices, a vertex is the part of the conic section that touches the major axis. So P and Q are the vertices, F1 and F2 are the foci, MN is the principal axis, and RS is the minor axis. PQ is the major axis. So those are key things. So now, using that ellipse method, let's now construct an ellipse. Using the eccentricity method, let's construct an ellipse with focus of 40 mm from its directrix. In other words, you draw a line. In other words, you draw a line. Before we go there, let's just see. In other words, you draw a line. This line is your directrix, DD. So you can just anywhere along the line. So 40 mm. If you measure 40 from this point, let's say to somewhere here, this becomes your what? Your focus, F. Got your focus, F. So the procedure is first of all draw DD, and you draw MN perpendicular to DD. Of course, if you are able to rule this line now with your T-square, you can easily draw this, or with your set square, you can easily draw the perpendicular to DD. So after that, you locate your focus, which is 40 mm away from DD. Then after that, the vertex P is found by dividing MF into what? 5 parts. So, like we said, how to divide the line again. We'll come here. This is MF. We want to divide into 5 parts. So, we have this 1, 2, 3, 4, and 5. So you join the 5th one to the last point here, and using parallel lines, you can transfer the line. Using your set squares, you can draw parallel lines to that. So we're told that the eccentricity is 2/3. So in other words, P is 2 points away from F. So this is 1, this is 2. So this is where you have your P. Okay, so that is what you can find there. So this is where you have your P. Now, having said that, you now locate any point. Let's call it 1. All right, any point 1. Locate any point 1. Position any point 1 on MN at the convenient distance from F and draw it parallel to the directrix. So we locate a point 1, any point 1, convenient distance from F, draw a parallel line to the directrix. After that, with center F and radius M1 times the eccentricity. In other words, you measure this radius. Okay, this is center F, this is M1, right? This is M1, this is radius M1. Let's assume radius M1 is 18. Let's assume radius M1 M1 is equal to 18. So what you want to do is M1 times E. So the radius will be 18 times 2/3. So this is 3A1, 3A is 6 times 2, that's 12. So in other words, you are going to use 12. Just a case, not that you are going to use 12. But based on this case, assuming M1 is 18, then it means that the radius will be what? 18 times 2/3, which is the eccentricity. And that will give us what? 12. So from F now, you open your compass to 12 and you cut the line, the line of 0.1. Okay, so you repeat the same thing for 0.234, all right, 2, 3, 4, 5, 6, as the case may be. So you also pick arbitrary point 2, 3, 4, 5 as much as you can. Okay, and what do you do again? You measure from M1 to 2 now. So that's from M to 2, that's M2. Multiply by directrix to give you the radius, and with that radius and point F, you cut the line 2 up and down. So do the same thing all through. At the end of the day, you join again as before. So that is how to draw an ellipse using the different methods that we have discussed. So thank you for listening. Bye for now.